Dear students, I welcome you all to this tele-learning session of physics focused at electromagnetic waves. Waves, as we all know, it is a mode of transfer of energy from one point to other, in which particle of the medium executes oscillatory motion and energy transfers in forward direction. But what happens? Centuries ago, people started asking questions that how the light wave, solar radiation, heat radiation from sun traveling so much distance in space and coming to earth. So, you may answer that thing as that they are electromagnetic waves and they do not require a material medium for their propagation. Yes, you are right, but with the same question a number of more questions came up in our mind. They are: what are electromagnetic waves? Why they do not require any material medium for their propagation? What is their origin? What are their properties? How they get propagate from one point to other? How they transfer energy, and many more questions. And to address these queries, we must set up the background, we must recreate the background for the development of discovery of electromagnetic waves. And for that thing, we must concentrate, or we must go back centuries ago, that in 1831, Faraday came up with the idea that a time varying magnetic field generates an electric field, that is E equal to minus d phi b by dt. That equal to, I can write this as minus d by dt of integration over s b dot ds, and this can be written as your that E equal to integration over a closed surface S minus del B by del T dot ds. This leads to the differential form as del cross E equal to minus del B by del T, and this suggests what? That a time varying magnetic field generates an electric field, which we otherwise called as EMF. Now, what happens? That if B equal to constant, then del B by del T equal to 0 and del cross E equal to 0. This suggests that your E equal to 0. This confirms that a time varying magnetic field generates an electric field or EMF. When the advances in electrodynamics is going on, a Scottish physicist, James Clerk Maxwell, was busy in addressing the discontinuity of total current across the plates of a parallel plate capacitor, and hence the inconsistency of Ampere's circuital law thereupon. Now, let us discuss that what do you mean by this? What do you mean by the inconsistency in your conduction current across the plates of the capacitor, and how Ampere's circuital law is inconsistent at this point? To discuss this thing, let us draw a parallel plate capacitor consisting of, this is one plate of the capacitor, this is the other plate of the capacitor, this is the conducting wire which is connected. Across this connection there is a battery here and there is a switch here. This is the other plate of the capacitor here. So, this is the positive terminal of the battery and this is the negative terminal of the battery. So, what happens here that when this switch is turned on, this generates a negative charge and this plate generates a positive charge due to a flow of current capital I. Now, let us draw a closed loop here. Let this loop is C1. If we will apply Ampere's circuital law at this point, then we can write integration over closed loop C1 B dot dl equal to mu 0 I, and this magnetic field here is dot, that is perpendicularly outward, and here that is cross. And the same analogy we will get if we will draw a closed loop here. But what happens if we draw a closed loop in the region between the plates? Let this is C2. When we will apply the same Ampere circuital law to the loop C2, you will get this is mu 0 into 0, which is equal to 0. Why? Because there is no wire here, so there is no conduction current. As a result, this B dot dl will be equal to 0, and this will give you that B in the region between the plates is 0. And this thing is the inconsistency in Ampere circuital law. The question is how the current becomes discontinuous here, how the current getting propagated on either side, but there is no current at this region. So, to answer this anomaly, Maxwell came up with an idea. He put a magnetic needle here, and what he observed, that there is a deflection of the magnetic needle, and this deflection of the magnetic needle suggests that there is a magnetic field prevailing in this region. And to his astonishment, what he also found, that this magnetic field at this point has got the same magnitude and direction as that on either side of the and at the outer side of the capacitor. This confirms that there exists a magnetic field in the region between the plates. Now, this analogy again draws another question, that from where this magnetic field has come from. And to answer this thing, Maxwell shows that when the charge across this plate is dragged, it gradually developed negative charges, and this plate gradually developed positive charges. As a result, there is a varying magnetic field prevailing in this region, and this varying electric field prevail in this region, and this varying electric field is generating the magnetic field here. But nobody was ready to buy this argument. Why? Because by that time it has already been established that only a current can generate a magnetic field. So, to address this anomaly, Maxwell came up with an idea. He suggested that this time varying electric field is generating a current in this region. This time varying electric field is generating a current in this region. He termed this current as displacement current, and he termed it as a displacement current because it is quite different from the conventional conduction current. Because conventional conduction current, as we all know, that is due to your transfer of charge. But this displacement current is something different from that. This displacement current is only there to generate the magnetic field, and he termed this displacement current ID equal to epsilon 0 del phi by del t, or he can say this as also epsilon 0 d phi by dt. That means, this displacement current comes into the picture, comes into the existence only when there is a changing magnetic electric field and hence changing magnetic flux. This idea of displacement current not only sorted out the discontinuity in conventional currents, discontinuity in conduction current, but also answered successfully the inconsistency of Ampere's circuital law. Now, to address the inconsistency, we can say that for the loop outside the conductor, outside the capacitor, C1 B dot dl equal to, he termed it as mu 0 IC. He termed this current as IC and this as IC. So, what happens that outside the conductor, this becomes equal to B dot dl equal to mu 0 ID. So, in general, he write this as integration over C B dot dl equal to mu 0 IC plus ID, and this give rise to equal to mu 0 IC plus epsilon 0 del phi E by del T. And outside the capacitor, this term will be 0 and only this conduction current will exist, and inside the capacitor this IC part will be 0 and there will be only displacement current. Now, if we will move slightly further, we can say that this conduction current and the displacement current are quite analogous. How they are analogous? Say this IC, which is equal to dq by dt, which is nothing but rate of your transfer of charge, and if we will come up as this ID is epsilon 0 d phi E by dt, and that equal to epsilon 0 d by dt of your epsilon, or this equal to E A, and this comes out to be epsilon 0 d by dt of q by epsilon 0 A into A, and again this comes out as dq by dt. But this dq by dt is not the previous one, rather this is the rate at which charge is deposited on the plates. And with this analogy, your Maxwell set up the stepping stone for the invention of electromagnetic wave. And from this idea, he came up with a proposition that a varying electric field, generates a magnetic field, and a changing B magnetic field in turn generates an electric field. So, this one changing magnetic field creates an electric field. That means that either of the time varying field creates the other field in a mutually perpendicular direction. And what happens here, that when this process once gets started, this automatically continues as a chain reaction and it creates time varying electric and magnetic field alternatively. And this basic idea that a time varying electric field generates a magnetic field and a time varying magnetic field generates an electric field creates the stepping stone for the discovery of electromagnetic waves. So, now with this idea we can say that displacement current as invented by your Maxwell is a revolutionary concept that not only sorted out the discontinuity in conduction current, but at the same time it also answered the inconsistency in Ampere's circuital law, and at the same time it create or it started or it puts up the stepping stone for the discovery of electromagnetic waves. What we have learned so far, that a displacement current, the discovery or the introduction of a displacement current has put up the stepping stone for electromagnetic, for the concept of electromagnetic wave to flourish. Now, let us discuss that how electromagnetic waves generated and how, what is the origin or source of this electromagnetic wave. Consider a charge q. Consider a charge q. When it is at a rest, it is associated with an electric field. But when this same charge is in motion, here by telling motion we can come up with two different things: uniform motion and this is your non-uniform motion. Or in other sense we can say accelerated motion. So, what happens that when the charge is at rest, it is only associated with an electric field, but when it moves, in addition to electric field, it also possesses a magnetic field. And the same is the case here. There is an electric field plus there is a magnetic field here. But what is the difference between the two? The difference between the two is that it is a constant field, but these fields are time varying fields. So, Maxwell proposed that an accelerated charge generates a time varying field, and which is the source for generation of electromagnetic wave. And what do you mean by an accelerating charge? An oscillating charge generated by an LC circuit is a classic example of an accelerated charge which generates time varying electric and magnetic field. And since we know that one changing field is the source of the other and creates the other in a perpendicular plane, we can say that an oscillating charge in the course of time will generate the entire electromagnetic wave. Let us now discuss that how an oscillating charge generates an electromagnetic wave. So, for this let us draw, so this is an oscillating charge here which generates a time varying electric field plus a time varying magnetic field. Now, what happens here? Say this is the frame here. So, say this is the frame here. This is the axis and this is say the z axis. Here this is x axis, this is y axis and this is your z axis. Let this time varying field, here this is 0, here this has a value, maximum value say this one, here again this is say 0. Now, in between these, let the electric field varies like this. So, it will create an electric field like this. We know that this time varying electric field will generate a magnetic field in a mutually perpendicular plane. So, the magnetic field will be like this. And this magnetic field in turn will generate an electric field here. Why here? Because as per Lenz's law, the varying magnetic field will generate an electric field, and as per Lenz's law, this field will oppose this one. That is why this is along negative y axis direction, which in turn will generate a magnetic field in negative z axis. So, you will see that once an electric time varying electric field is set up, it is in turn created the magnetic field in a mutually perpendicular direction, and this continues as a chain reaction which makes this wave propagate along positive x axis direction. So, what we will observe that here the electric field is along y axis, the magnetic field is along z axis, and the wave propagate along your x axis. So, we can say the direction of propagation of a wave, that is this v vector, is along E cross B, that is it is perpendicular to both electric field vector and magnetic field vector. This also suggests that an oscillating charge generates an electromagnetic wave which is a self-sustaining and self-propagating. By meaning self-sustaining, that means once a varying electric field is generated, that automatically creates a varying magnetic field, and the process continues as a chain reaction, and the wave propagates in a direction perpendicular to both electric and magnetic field vector. So, what we have learned so far, that an accelerating charge radiates an electromagnetic wave, or we can say an electromagnetic wave is a wave radiated by an accelerating charge. It consists of coupled electric and magnetic field in a mutually perpendicular direction, and this electric and magnetic field vector is also perpendicular to the direction of propagation of a wave. If we will analyze the expression for electric and magnetic field vectors, then we can say that your electric field vector E equal to your Ey j cap, and I can write this as E0 sin kx minus omega t j cap, where k equal to 2 pi by lambda, which is the propagation constant. Similarly, for B vector, we can write that this is Bz k cap, which is equal to B0 sin kx minus omega t k cap. These equations suggest that both electric and magnetic field vectors lie in same phase. That means E vector and B vector lie in same phase. What do you mean by same phase? That is, when electric field is 0, magnetic field is 0, and when electric field attains its maximum value, magnetic field also attains its maximum value. And if we will move slightly further, we can say that the ratio of their amplitudes E0 by B0 equal to capital C, which is equal to 3 into 10 to the power 8 meter per second, which is nothing but your speed of light. That means what? That these electromagnetic waves propagate with speed of light, which means that this oscillating electric and magnetic field in mutually perpendicular planes propagate with the speed of light in free space, and this is true for all electromagnetic wave traveling in free space. What we have learned so far, that an accelerated charge generates an electromagnetic wave. In other sense, we can say electromagnetic wave is a wave generated or radiated by an oscillating charge or accelerating charge. It consists of coupled electric and magnetic fields in mutually perpendicular planes, and they are also perpendicular to direction of propagation of wave. In other sense, we can say that the velocity of electromagnetic wave is along E cross B vector, that is, it is perpendicular to the plane containing E vector and B vector. We have also discussed that the electromagnetic wave move with the speed of light in vacuum. That means, irrespective of their nature, frequency, all of them travels with the same speed, that is speed of light in vacuum. And if we find out the ratio of their amplitude, we have discussed that E0 by B0 equal to C, and which is nothing but your 3 into 10 to the power 8 meter per second. Now, all electromagnetic waves, in electromagnetic waves, both electric and magnetic field lie in the same phase, and they transfer energy in the direction of propagation of a wave. From this analogy, we can say that this is C equal to 1 by square root of mu 0 epsilon 0, and which is equal to 3 into 10 to the power 8 meter per second. For any other medium, other than free space, V equal to C by N equal to 1 by square root of mu epsilon, where this N is nothing but refractive index of the medium. If we proceed slightly further, we can say that V equal to C by N, that implies N equal to your C by V. This equal to 1 by square root of mu 0 epsilon 0 divided by 1 by square root of mu epsilon. This gives rise to refractive index as mu by mu 0 into epsilon by epsilon 0 square root. This comes out as n equal to square root of mu r epsilon r. This shows that the optical effect, electric effect and magnetic effect are not different, rather they are coupled to each other, and the optical effect of a electromagnetic wave is mostly due to electric field vector because of its greater amplitude. Now, let us discuss that how energy gets propagated due to propagation of electromagnetic wave. And for this, we can say that when electromagnetic wave moves or travels, energy propagates in the direction of propagation of a wave, and this energy is equally shared by electric field and magnetic field, such that the average energy density becomes your U bar equal to U bar electric field and U bar your magnetic field. This can be written as half epsilon 0 E RMS square plus 1 by 2 mu 0 your B RMS square. Why we are taking the RMS value? Because these electric time varying electric field vectors and magnetic field vectors are alternating in nature, that is, their magnitude changes continuously and polarity alters after periodic interval of time. So, what happens here? We can write this as half epsilon 0 E naught by root 2 rho square plus 1 by 2 mu 0 your B 0 by root 2 rho square. This comes out to be U bar equal to 1 by 4 epsilon 0 E 0 square plus 1 by 2 mu 0 4 mu 0 B 0 square. So, this is the expression for average energy density in an electromagnetic wave. Let us now find out that we have your E 0 by B 0 equal to C. That implies your B 0 equal to your this B 0 equal to E 0 by B 0 equal to your C. Now, from this we can write that this B 0 square, we can write this as mu 0 epsilon 0 E 0 square. So, 1 by 4 mu 0 B 0 square equal to 1 by 4 mu 0 into mu 0 epsilon 0 E 0 square. So, this leads to, you can say, 1 by 4 epsilon 0 E 0 square. Substituting this value here, we can say that U bar equal to 1 by 2 epsilon 0 E 0 square equal to epsilon 0 E RMS square. Similarly, we can prove that U bar equal to half mu 0 B 0 square equal to 1 by mu 0 B RMS square. With this idea, let us now find out what is the intensity of electromagnetic wave. Now, to find out the intensity of electromagnetic wave, let us write that the total energy of electromagnetic wave U equal to energy density into volume. So, this becomes equal to U bar, and this volume becomes C delta T is the length of cylinder to which this electromagnetic wave is confined into area of cross section of that cylinder. So, this becomes equal to, we can say that intensity equal to energy divided by your area into time, energy per unit area per second. So, this becomes something equal to U by A delta T, which is nothing but equal to U bar into C. That implies intensity becomes equal to C epsilon 0 E RMS square equal to C by mu 0 B RMS square. This shows that intensity is directly proportional to square of RMS value of electric field intensity and also square of RMS value of magnetic field intensity. So, from this we can say that when electromagnetic wave propagates, in the direction of propagation energy transfer occurs. Now, electromagnetic waves like light wave, they are transverse in nature. Why? Because the electric field vector and magnetic field vector oscillates in mutually perpendicular direction, and they are also perpendicular to direction of propagation of a wave. Now, secondly, we can say that these electromagnetic waves are not influenced by electric and magnetic field vectors or electric and magnetic fields. So, why? Because these electromagnetic waves consist of photons, and photons are charged neutral particles. So, they are neither deflected by electric field nor by magnetic field. And lastly, we can say towards the property of electromagnetic wave, that this electromagnetic wave exhibits phenomenon like reflection, refraction, interference, polarization, diffraction like ordinary round light waves. So, with this idea, we have discussed that what are electromagnetic waves, how these electromagnetic waves have originated, how they propagate, then what is the energy of electromagnetic wave, what is the phase of electric and magnetic field in electromagnetic wave, what is their intensity and other properties. And with this idea, let us come to a question that what is the origin of electromagnetic wave. We have discussed that an oscillating charge or an accelerated charge is the origin of electromagnetic wave, which generates a time varying electric and magnetic field, which recreates the oscillating electric and magnetic field in mutually perpendicular direction, and the same is a self propagative and a self sustainable process. That means, once this variation electric field variation has started, it automatically generates an electromagnetic wave. Now, why it does not require a material medium for its propagation? Since electromagnetic waves consist of photons, because of particle nature, it does not require a material medium for its propagation. Secondly, since it consists of coupled electric and magnetic field in mutually perpendicular direction and one creates variation of one creates the other, they do not require a material medium for their propagation. Third thing, why do EM waves are transverse in nature? Since it consists of electric and magnetic field in mutually perpendicular direction and they are also perpendicular to the direction in which the wave propagates, that is why we can say that your electromagnetic wave is your transverse in nature. Now, why do second question, why do all electromagnetic wave travel in a free space with the same speed? Is it true that when they move in any other medium or any medium other than free space, they travel with the same speed? Justify your answer. Now, we know that each electromagnetic wave travel in free space such that the amplitude of electric and magnetic field vector is c, and which is 1 by square root of mu 0 and epsilon 0. But what happens when it comes to any other medium? We know that c by v equal to n. In case of electromagnetic waves, c equal to f lambda. This lambda can change if lambda goes up, f goes down, so that c remains constant. So, when electromagnetic wave travel from one medium to other, this frequency remains fixed, but this wavelength changes. Due to that reason, the velocity with which they travel in any other medium other than free space also changes. Why? Because with a differing speed, they have different refractive index, which in turn will decide that what will be the speed with which they will move. So, c by v equal to n, since n refractive index is different for different wavelength, that is why different electromagnetic waves will travel with a different speed when it enters into some medium other than air. Next question, do EM waves transfer energy during propagation, and if yes, then what is the energy density and intensity of electromagnetic waves? Yes, electromagnetic wave transfers energy during their propagation. How we can say? That we are seeing the vision that we have due to sun, due to solar light, due to light wave is the example. We are feeling the heat on our skin due to sun rays is the example that electromagnetic wave transfers energy during propagation. By getting this solar energy, photosynthesis occurs in plant, different biological processes occur, and this energy from sun is responsible for these processes. So, electromagnetic waves definitely transfers energy during propagation, and about energy density and intensity, both we have already discussed that they are proportional to square of RMS value of electric as well as magnetic field. With this idea of electromagnetic wave, let us now discuss about electromagnetic spectrum. The orderly distribution of electromagnetic waves in accordance with their wavelength or frequency into distinct groups having widely differing properties is called electromagnetic spectrum. Let us now draw the electromagnetic spectrum and analyze the different series thereon. Suppose this is a line, this is a line here, this is in order of higher frequency side, and we know that c equal to f lambda. If f increases, lambda decreases. So, this will be definitely smaller lambda value. Say this region here is your visible region. So, we will analyze this thing. This is your visible region. Here V, I, B, G, Y, O, R. This violet has got a typical wavelength frequency of 7.5 into 10 to the power 14 Hertz and a wavelength of about 400 nanometer. This red light has got a frequency of 4 into 10 to the power 14 Hertz and a wavelength of about 750 nanometer. On this side from violet to here, this is ultraviolet, then this is X-rays, then this is your gamma rays. On this side we can say this is your infrared, this is your microwaves, and the last one is your radio waves. So, in order of increasing frequency, there are radio waves, microwaves, infrared, then this is visible range or visible spectrum, then ultraviolet, then X-rays and gamma rays. So, what we can say that this higher frequency means greater energy, and hence more dangerous. So, we can say that as we move from low to higher frequency side, we can arrange these radiations into following states, that radio waves have the lowest frequency and highest wavelength, then came the microwave, then your infrared rays, then comes your visible rays, then comes ultraviolet, then X-rays, and lastly gamma rays, which is the most dangerous one, having the most prominent and most profound penetrating power. Now, what happens that if we will study the uses of these electromagnetic waves, your radio waves are broadly used for broadcasting radio wave signals and other communications. Then microwaves is responsible for your cooking, then communications and satellite transmission. Remember your cell phone transmission and other transmission in radar and sonar etc. All these things occur in microwave range. Infrared rays have got this vision or cooking, thermal imaging, short range communications, television remote controls and thermal sensing etc. Visible light is responsible for vision, photography, photo illuminations etc. Ultraviolet rays are used for your security, marking, fluorescent lamps, detecting forged banknotes, then purification of water etc. X-rays are used for observing internal structure of objects, airport security scanners and medical X-rays. And lastly, the gamma rays is responsible for your sterilizing food and medical equipment, detection of a cancer and its treatment and other processes to follow. Now, with this idea of electromagnetic radiation, let us now come to certain conceptual questions. The first one, name the constituent radiation of electromagnetic spectrum which is used in satellite communication. Remember one thing, that a part of electromagnetic spectrum that is coming under radio wave and also under microwave comes under satellite, comes or used for satellite communication, but basically it is the microwave which is used in satellite communication. Not only satellite communication, but also for cell phone communication, for your FM communication and other broadcasting purposes, these microwaves are used. Then second, what is the name the constituent radiation which is used to study crystal structure? It is the X-ray that is used to study the crystal structure. What is the radiation which is absorbed from sunlight by ozone layer? This is the UV radiation which is absorbed from sunlight, which is the dangerous fragment from the sunlight which is absorbed by ozone layer. Nowadays, we are hearing that due to your chlorofluorocarbon and other global warming and other factors, there is hole in ozone layer which causes this hazardous UV rays to reach the earth, and it causes mild skin irritation to cancer. Now, which is the name the constituent radiation of electromagnetic spectrum which produces intense heating effect? This is the infrared that causes intense heating effect Come to the next question. Name the constituent radiation of electromagnetic spectrum which is similar to radiation emitted by decay of radioactive nuclei. It is the gamma rays which is emitted during decay of, which is similar to or which is emitted during decay of radioactive nuclei, which is produced by bombarding a metal target by high speed electron. This is the X-ray which is produced by bombarding a metal target by high speed electrons. Name the constituent radiation which is used in the radar. It is the microwave which is used in a radar communication. Then identify the part of electromagnetic spectrum which is used to photograph internal parts of a human body. This is the X-ray which is used to study the or which is used to photograph internal parts of a human body, because X-rays, because of its high frequency, is so much penetrating that it can penetrate human flesh, and of course, it cannot penetrate the bones. That is why it is used to photograph internal parts of a human body. Then which is used for taking photographs of the night sky during night and foggy conditions? It is the infrared rays. Infrared photography is used to take the picture of night sky. Then which radiation or spectrum, which part of electromagnetic spectrum is used to create sense of a vision in human retina? This is the visible spectrum or visible light which is used to create sense of a vision in human retina. Now come to the next question. Identify the part of electromagnetic spectrum used for the following and arrange them in increasing order of their penetrating power. Bit A, which is used for water purification. It is the UV light which is used for water purification. Then for remote sensing, it is infrared rays, and for treatment of cancer, it is gamma rays. And among them, the gamma rays have got the highest frequency and hence the highest penetrating power, and the infrared rays have got the comparatively lower penetrating power because of its lower frequency. So, in order of increasing penetrating power, they can be arranged first IR rays, then UV rays, then gamma rays. Hope we have journeyed successfully through the arena of electromagnetic waves. Thank you.